The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, we are live.
Good afternoon, and welcome to the FTTH Council Europe webinar series. My name is Vincent Garnier. I'm the Director General of the FTTH Council Europe, and I will be moderating this session. The FTTH Council Europe is a trade association regrouping 150 companies covering the full spectrum of the FTTH value chain. Our mission is to promote the development of full fiber network as the most sustainable, future-proof technology, which will enable a green and digital Europe. This webinar is one of the multiple actions we undertake to share market and technology information to the large FTTH and telecom ecosystem. So before I introduce the subject of today, let me briefly mention the next two webinars in our series. On June the 16th, our members, CETIX, Keypro, and Packetfront will present a session titled Break Down Network Boundaries. And on June the 30th, the Council's Investor Committee will release and introduce its Guide to Successful Fiber Business Models. Watch out for invitation and communication regarding both events. Just some housekeeping item about this session. Within a week, you and all registrants to this webinar will receive an email with access to the replay of the webinar and to the slide deck which have been used today. Now, you can ask questions during this session by typing them in the dedicated box on the platform. We will try and address them, or most of them, time permitting, at the end of the session. And then, without further ado, let's move to the theme of today. Historically, the FTTH Council has focused on bringing fiber to the home. Today, this is not enough. What truly matters for users is to bring the full potential of fiber to the end device of the user. With the increase of bandwidth brought by fiber, we see more and more gigabit services being offered. How can this quantity of data be transmitted over Wi-Fi? From this perspective, is Wi-Fi 6 a luxury or a necessity? And what needs to be done to manage Wi-Fi 6 and properly benefit from its full potential? These are some of the questions that our speakers will address in this session titled Separating the Facts from the Fiction, Wi-Fi 6 Demystified. And it's my great pleasure to introduce you to our speakers today. Bill McFarland, CTO at Plume. Good afternoon, Bill.
Good morning, very early morning for me, actually.
Oh, yes. Yeah, that's right. You're calling from the US.
That's correct.
I think. Well, thanks for being with us at such an early hour for your time zone. And with you is Ronan Kelly, CTO at Adtran. And good afternoon, Ronan. As far as you're concerned, you're based in Ireland, so this is definitely afternoon.
It's definitely easier for me. Good afternoon, Vincent, and to everybody else as well.
So thanks really for being with us and sharing your knowledge and expertise, your, I don't know, demystifier in chief in your respective organization. So I think we start with Ronan, and Ronan, the floor is yours. I think you just need to move to presenter mode and share your slide now.
Perfect. Thank you, Vincent. Appreciate the introduction. So good afternoon, everybody. Hopefully you can all see my slides. First of all, welcome to the latest in Fiber to the Home Council webinar series. As Vincent said, today we're going to focus on separating facts from fiction and focus in on demystifying Wi-Fi 6. I'm sure many of you in the audience already know who I am due to my previous presidency with the Fiber to the Home Council Europe, but for those that I haven't had the pleasure of meeting before, as Vincent said, I'm Ronan Kelly and I'm Adtran's Chief Technology Officer for the EMEA and APAC regions. For the operators listening in on this call, and I know there are many of you listening in today, you guys really need to pay attention to what's going to get discussed today, because there are a number of major movements playing out in the industry as we speak that are going to come together collectively. And fundamentally, they're going to break your customers' networks. quite possibly they're going to break your call center. And there's a really strong potential for many operators, they may even break your business model. So I think it's really important that you pay attention to some of the insights that we're going to share with you guys today during the presentation. At Adtran, we've been involved in access networks since the internet was a dial-up experience, and we've watched the industry grow from the very original ADSL, 11 megabit per second type connections, right through the various different variants of VDSL technologies and DOCSIS technologies. And now we're finally at the point where fiber has become the de facto when it comes to broadband infrastructure investment, which is a huge milestone for us to achieve now, and something I know the council has been pushing really, really hard to try and make sure that's happened. And it is now finally starting to happen. If we look, I borrowed a slide here from one of my colleagues, Eric Joyce, who's the chair of the Fibre to the Home Council Europe's Market Intelligence Committee. And on the slide, we see a lot of data that the council's partner iDate have helped compile that gives visibility with regard to the level of fiber penetration that we're seeing across Europe, or more importantly, the work that's been done so far to date, which is represented in the pink bars, versus the work that remains to be done in getting ubiquitous fiber coverage across Europe. And what we see very clearly is that we've made some fantastic progress. Over 50% of European households now have access to a fiber to the home connection, should they choose to avail of it, which is a massive, massive important milestone. However, we also see that there's quite a bit of work still to be done, particularly up towards the top of the chart. We see some of the main population centers still have a lot of work to do with regard to getting ubiquitous fiber coverage. However, the fantastic news is that most of those countries have already mobilized. They already have a very large number of operators, including their traditional incumbent PTT operators, are now investing heavily in fiber infrastructure. And what we're seeing now is there's a huge focus on delivering against the targets that were set down in the European Electronic Communications Code, which, as a reminder, was to deliver by 2025 network connectivity into every household that was capable of gigabit connectivity. So we've got 3.5 years yet to play with to get ubiquitous coverage for full fiber across Europe. So that's a very short period of time from which we've got to change this graph on the screen from being predominantly blue in the larger population centers to being predominantly pink. Now, why is this important in the discussion about Wi-Fi, and particularly Wi-Fi 6? Well, we see the fiber foundations that are being laid today as we speak in every city, every major population center across Europe. Those foundations are going to serve as the foundations that's going to transition our societies from being normal, traditional connected societies to becoming true gigabit societies. And this is going to have very strong implications with regard to the availability of gigabit service rates. And one of the things that we've seen very clearly is as we get more and more ubiquitous fiber, what follows very quickly is more and more cost-effective gigabit services. And we see that represented on the screen now is just a sample snapshot of various different operators across different countries in Europe, where they're now really starting to drive the democratization of gigabit connectivity. We see in the top left-hand side service rates as low as £25 per month for a symmetric gigabit experience. And all the way over, some of the ones on the higher end of things, still coming in underneath £100 per month. The gigabit experience is really starting to fall into the realm of the elastic spend that many households have for broadband connectivity. And this is going to have implications with regard to the end users. As we start to bring those larger and larger pipes into the home, the expectation is the users are going to want to be able to utilize those pipes. They're going to want to have that gigabit connectivity to the primary devices that they interact with the rest of the world through. And when they don't have that experience, that's when we can expect the call center volumes of complaints and fault calls to increase and drive the cost of the operators. This is further compounded by the number of devices that people are connecting onto the network. This is a chart by a company called Audience Project that they published a report that covered the growth in devices connecting to the network in homes across all the main population centers around the world in the developed world. And they covered it from 2018 to 2020. And what we can see is there's roughly around a 15 to 20% growth rate in that period. Now, what I find quite interesting with these numbers, you know, they're talking an average number of devices in and around 9 and 10 devices per household. I think one of the things we have to remember here is these are averages. And, you know, for those households like your grandparents' household that have 1 device or maybe 2 devices, they're pulling down that overall average. I think in most households that, you know, where you've got parents in their kind of mid-30s, early 40s, etc., they've got a couple of kids in the mix, we typically expect to see in the range of around 20 devices per household, if not higher. I know within my own home, I'm acknowledging I'm a lead user. Like, we've had more than 40 connected devices in our household for at least the last 2 or 3 years now at this point. And that's something that continues to rise year on year, and we don't anticipate that slowing down anytime in the near future. How the networks are getting used as well is continuing to evolve more and more towards a media distribution network. And we see now we're at the point where across all of the main streaming platforms now, there's over 1 billion paid subscriptions across the world collectively with all of those streaming platforms. So users are expecting now, as they avail of services, that, you know, they'll sign up to a cloud-based delivered service, and they expect to be able to have access to that service in a high quality, stable fashion throughout their entire household. It's not a case that they want to be stood right beside the access point in the hall just so that they can stream their favorite 4K TV content. A few things that become very clear is our networks must be robust and ubiquitous throughout our homes so that the customers, you know, if they can't enjoy their TV experience, they're going to get very irate very quickly, and they're going to drive support calls into the operators. The networks are going to get busier and busier as the content is streamed to more and more connected devices, but also as the fidelity of that content continues to increase. We're now very much in the 4K era, and if we look on the main streaming channels from Netflix or Amazon, etc., Disney Plus, 4K content is proliferating with all of the new titles that are being released. Our dependency on the networks is also increasing. You know, not only do they secure our homes, they also connect us increasingly to our workplaces, as we've all found out over the last 18 months. So that reliability becomes increasingly important. We're now in that period where Wi-Fi, it's no longer a luxury. I remember when I first started interacting with Wi-Fi, it was in early 2000, and you see on the bottom left-hand, there's an old Cisco PCM-CAA Wi-Fi adapter that I used to have to borrow in work from a pool of adapters that were shared amongst the engineers, purely because of the expense of the equipment. The industry continued to evolve, and we saw some early entrants into the industry, the likes of Linksys and that, during the 802.11g, the 54 megabits per second era. Linksys really secured strong market adoption, but it was still very much the preserve of lead users out there within the marketplace. It was only as we went into the Intel Centrino era and with the emergence of Wi-Fi connected devices like the iPhone that we really started to see Wi-Fi get democratized across households around the world. But predominantly, as operators started to provide Wi-Fi as a bundled piece with the broadband connectivity, it was really on a best effort basis. It was kind of, they were doing the users a favor by providing them with this Wi-Fi gateway. And if it wasn't working great, you know, tough, we're only responsible for the broadband experience. But what we've seen now as we've moved over towards Wi-Fi 5 and streaming has become a ubiquitous part of everybody's lives, consumers don't tolerate that anymore. If the operator isn't willing to take control and help them address their Wi-Fi challenges, then users will churn. They'll move on to the next operator. The way I describe it to operators when I speak to them is users don't buy broadband, they buy Wi-Fi. When things break, they say the Wi-Fi is not working. They don't say the broadband's not working. So now we're moving into the era of Wi-Fi 6, and it's critically important because, as I mentioned earlier, we're also moving into that era of ultra high definition experiences, whether it's in video streaming or gaming, or whether it's in video calling, like what we're doing now today, and in a work from home type environment. So we need something that can deliver more than what Wi-Fi 5 was capable of delivering. If we look at some of the main benefits that Wi-Fi 6 brings to the table, first of all, from a modulation perspective, we're getting much greater density in the modulation schemes that are applied. So we've got a 1024 QAM modulation scheme, which is a step up from the 256 QAM that we had with Wi-Fi 5, And realistically, in usable capacity, it gives us about an extra 25% of usable capacity. We've also got the OFDMA implementations as well. And what that allows us to do is it allows us to subdivide the spectrum that's available between the users on the network. But more importantly, we can subdivide even further, not just on frequency, but on the time domain as well, so that we can give slices of capacity to users on the network. And that's really important as we move into trying to implement quality of service across the network, or to go further and use the phrase du jour these days of network slicing. We have that capability in a Wi-Fi 6 environment. There's a big focus on upstream as well, with multi-user MIMO being applied in the upstream direction, so that we can achieve much higher capacities when we're doing activities like what I'm doing with you now today in video calling, etc. We've also got the Wi-Fi industry trying to align itself better with the IoT space as well. So the concepts around target wait time, where devices that particularly are operating on battery power, they can avoid some of the power consuming activities of gaining access to the network, where they have to listen out to see if any users are on the network. Instead, they can pre-schedule transmission time with the access points, so that when they're ready to send at a set time of day, they just send, and the access point makes sure that the channel is clear for them to do that. We're seeing the broader use of 160 megahertz channels as well, and that's not new. That was available in Wi-Fi 5, but it didn't really make its way into a lot of end devices to take advantage of that, whereas we expect in the Wi-Fi 6 world that will become much more ubiquitous out there. Probably the biggest and most important change, though, is with Wi-Fi 6E, and that's where effectively we're doubling the available spectrum for use in Wi-Fi, so that as the original 5 gigahertz spectrum starts to become congested, in markets like the United States, we've got a new 1.2 gigahertz worth of spectrum available in the 6 gigahertz band. So we can start to use that initially between access points, etc. But then as newer devices, newer electronics comes out, whether it's laptops or smartphones that can avail of that 6 gigahertz spectrum, they can also take advantage of that additional capacity for a better user experience. Unfortunately, in Europe, we've only got 500 megahertz of that spectrum available at this point in time. Hopefully that's something that will improve into the future. As with all aspects of the telco infrastructure these days, we see a strong push by the operator community towards open equipment implementations. We see from the operators that they're sick and tired of being locked into closed ecosystems. So now as they're moving towards this new world where particularly they've got multiple pieces of equipment inside the home, where they're trying to deliver a meshed experience to provide whole home coverage with a very high quality of experience, the challenge that they've got is if they deploy a closed solution from a single vendor, then they're tied into everything from supply chain risk through to the innovation capabilities of that single vendor. So what we're seeing now is a strong push by the operator community towards an open implementation, utilizing approaches like Opensync, where they can achieve the same whole home coverage, but they can use a multitude of different vendors to achieve that coverage. And they can mix and match between the vendors. So that way they can get independence from the chipsets that are applied in the equipment. They can get operating system independence. They get choice in who they procure their software for doing automation, analytics, telemetry, even the subscriber application tools, because there are open interfaces that can be developed to. So as they move forward and start to build out the infrastructure throughout the homes based on these open implementations, they can open up a whole new pool of vendors that can feed into that open ecosystem and bring around a whole new range of innovations that perhaps wouldn't be available in such a timely fashion from the traditional vendor community. The last point I'll touch on is the cost of all of this equipment. There's no question that there's some very sophisticated equipment coming out now in this new Wi-Fi 6 era that can deliver an exceptional consumer experience, and particularly when augmented with cloud automation to really optimize and maintain that environment. But it's not cheap. It costs quite a lot of money. And this is where we're starting to see a lot of the operators revert back to the very original business model that went with telecoms. When the phone lines were being built out, the cost of the original handsets was prohibitive for many users and served as a major barrier to adoption. And what the early phone companies did was they provided that handset as a service, where basically you would pay an equipment rental as a component on your bill every month. And we know how that worked out. For many of those operators, they got to rent that same piece of equipment for 20 plus years. And it more than paid for itself. And this is what we're now starting to see across Europe, is there's a number of innovative operators, both tier 1 and tier 3 and everything in between, where they're starting to deliver a superior Wi-Fi package as part of their lineup. And they're renting the equipment to the consumer as part of that, with a fixed term contract as well, which helps stem the ARPU decline that they're seeing from the loss of services to over the top. So they're now shoring back up those declines with new revenue streams coming in from the equipment rental. But also, when it's their equipment providing that gigabit experience and that gigabit lifestyle throughout the user's home, it's much more difficult for the user to just quickly flip over to a different provider, because now they've got to reconsider how their whole home is networked. And then also it opens up the opportunity, as I mentioned earlier, because of all the innovation that's coming now with the open implementations through Opensync, it opens up the opportunity for new revenue streams for the service provider. And Bill, who's going to speak now in a couple of seconds, will talk you through some of the capabilities for opening up those new revenue streams when you build on top of that Opensync architecture. So with that, I'd like to give it over to Bill McFarland, and Bill is the CTO for Adtran's partner via our Opensync implementation with Plume Networks. So Bill, over to you.
And while Bill is getting ready with his slide deck, may I remind you that you can still ask questions, type this question in the question box. We will address them at the end. Any question to Ronan or any question around this topic will be addressed by both Bill and Ronan. We can see your slide, Bill.
Okay, do you see my slide correctly?
Now, yes, absolutely. Thank you.
I see that somehow it's skipped ahead a little bit. Let me go back to the beginning. That's a good place to start. So I'm Bill McFarland. Shown on this slide here are the main advantages of Wi-Fi 6. Ronan's already been through this a little bit, so I'll try to go quickly. Most Wi-Fi 6 devices can use 160 megahertz frequency channels. These are twice as wide as earlier Wi-Fi devices, and that allows them to go twice as fast as previous generations of Wi-Fi. We have orthogonal frequency division multiple access, currently commonly abbreviated OFDMA, which allows the delivery of small packets simultaneously to a large number of devices. And that improves the efficiency of networks, particularly for networks that have a lot of kind of smaller, lightweight devices in them. You think about a home that has a large number of Wi-Fi devices in it. Typically, a large number of those are IoT devices, things like light bulbs, thermostats, etc. Those devices require a relatively modest amount of traffic, but servicing them individually is very inefficient. So OFDMA really helps with that. Network slicing reserves throughput in the network for high priority real-time traffic, and that improves the reliability of audio and video in the home. There's a feature called target wake time, or TWT. This saves power by reserving the airwaves for sleeping devices. These sleeping devices periodically wake up to send and receive traffic. And if when they wake up, the airwaves are already clear, they can very efficiently send and receive their traffic and go back to sleep, rather than having to stay awake longer waiting for other devices to get out of the way. So that ability to reserve time on the airwaves really helps with battery life, actually. And then there's Wi-Fi 6E. The E stands for extended. It makes use of the new 6 gigahertz spectrum, which is allocated in the US and other geographies, providing more spectrum to avoid interference and use wide channel bandwidths. But it does complicate things, as we'll talk about later. Now, all of these features kind of work well out of the box in an ideal environment. If you have just one access point and no interference, if you're effectively in a Wi-Fi vacuum, then these features work great just as it comes on the AP by itself. But in practice, few environments are really a Wi-Fi vacuum. More realistic environments that Wi-Fi works in have 3 different scenarios of interference between access points. There can be interference from one neighboring Wi-Fi system to your home Wi-Fi system, right? So you can have these neighboring Wi-Fi systems that might not be centrally managed. Each AP is making independent choices about how to operate. And this represents kind of foreign interference that comes into your home, potentially from your neighbors. There are also environments such as apartment complexes that have multiple APs that interfere with each other. But the unique thing about these environments is that all of these APs might all be part of the same centrally managed system. For example, a service provider might have a contract with an apartment complex, and it might make use of a centrally managed system such as Plume's to manage all the APs from the cloud. This represents kind of like in-system interference, and it opens the possibility of doing some other things in order to make the situation better in that case. Finally, as Ronan pointed out, there's a move towards having multiple access points in a single home to ensure full coverage of the home, high data rates throughout the home, and so forth. And so here in this scenario, you actually have self-interference. Your own traffic, as it goes through multiple hops through the network, becomes your own congestion in your own home. And of course, a given home can be experienced potentially all three of these types of interference simultaneously. There's foreign interference, in-system interference, and self-congestion. To make Wi-Fi 6 and 6E work well in these types of real environments, it turns out you really need centralized intelligent management. It's kind of counterintuitive, but Wi-Fi 6 requires actually more management than previous generations of Wi-Fi, not less. The management required can be broken into 4 categories, and I'll go through them for you to understand better what types of management, what this management is that's actually required. But the 4 categories are band management, channel management, steering management, and time management. So to demonstrate the complicated band management requirements that Wi-Fi 6 brings into play, we're going to take a look at a particular example. Assume you have a network with APs that have 3 radios. So it's effectively a tri-band AP in which 2 of the radios have a 2x2 MIMO capability. Those are radios that can go about twice normal speed. We'll call it baseline speed. And one of the radios has a 4x4 MIMO capability, and that allows it to go at a 4 times baseline speed. A common hardware arrangement would be to have one 2x2 radio in the 2.4 gigahertz band to serve legacy clients. For example, in this diagram, it's labeled as channel 6. The other 2x2 radio in the lower half of the 5 gigahertz band, this might be on a frequency channel called channel 42, for example. And the third 4x4 radio tunable between the upper half of the 5 gigahertz band, or it can be moved into the 6 gigahertz band. In this diagram, they're labeled channel 155, lower half of the 5 gigahertz band, and what I've labeled as channel 615 in the 6 gigahertz band. Now, the first network topology that I show, the network is arranged much as it would be if it were a Wi-Fi 5 network. The backhaul is in the 5 gigahertz band using the 4x4 radio, the highest performance radio. And in some systems such as Plume's, that radio can also be used for Wi-Fi clients to attach to. This is quite valuable, actually, because it allows devices with a strong Wi-Fi capability, such as a MacBook with its 3x3 MIMO radio, to connect at full speed. Now, you might think this topology can be improved by putting that backhaul connection in the 6 gigahertz band. And on the right-hand side of this slide, we're showing an example of that. However, while using the 6 gigahertz channel for the backhaul might improve the backhauling, it would avoid interference and allow clean use of a 160 megahertz wide channel in the backhaul. If the MacBooks don't have 6 gigahertz capability, and they don't today, obviously, the quality of the connection to the client is actually degraded. So the question becomes, which of these topologies is better? The one with the MacBook connected to the 4x4 radio in the 5 gigahertz band, or the one with the 6 gigahertz backbone, but the MacBook's connected on a 2x2 connection to a less powerful 5 gigahertz radio? It turns out that, as I like to say, I'm not smart enough to answer that question. To get benefit rather than degradation from Wi-Fi 6E, what Plume does is it uses machine learning, artificial intelligence effectively, implemented in the cloud to understand the pattern of device usage, interference, and services coming from individual homes to proactively optimize the network for the traffic that will be present. Essentially, you have to learn, does the network need a lot of backhaul capability? Does the network have a lot of these high capacity clients in it? Do these high capability clients want to move a lot of traffic frequently? All of those factor into the decision about which of these topologies is actually better and which is worse. And so again, when you think about Wi-Fi 6 coming, this availability of the 6 gigahertz band, it becomes more complicated, not less complicated, to decide how to correctly configure your networks. Now, along with choosing which band each radio should operate in, intelligent selection of the frequency channel for each radio also benefits Wi-Fi networks. This challenge has been present in previous generations, but Wi-Fi 6 brings 2 additional complications to thinking about channel allocation. First, Wi-Fi 6 devices generally include the ability to operate at 160 megahertz wide channels. So this is nice because it can double the speed, and in many geographies, but the disadvantage is that in many geographies like the United States, Europe, there are only 2 160 megahertz channels available. And so that networks that use 160 megahertz channels can be very vulnerable to interference. If you're in an apartment complex, everyone's trying to use 160 megahertz channels, there's only 2 different frequencies to choose from. Obviously, you're going to have a lot of channel sharing, you're going to have a lot of interference. Now, the question becomes, when should 160 megahertz be used? Which homes really deserve it? Using 160 megahertz also throws interference into neighboring homes. So the question is, who and how much is it damaging the experience of other users in your own system? So again, we have a complicated set of decisions to make regarding that. When we look at another complication that Wi-Fi 6 brings, which is this technology called BSS color, that's a tool that Wi-Fi 6 brings to help with interference from overlapping networks. The diagram here shows a theoretical arrangement of 4 homes on 4 different frequency channels. In this case, they're just labeled 1, 2, 3, 4, and a variety of colors. The colors is a notion in Wi-Fi 6 that allows an AP to transmit even when a signal is present on the same channel if it's coming from a different color. Generally speaking, the way Wi-Fi works is it's what we call listen before talk. If there is any other Wi-Fi system in the whole area transmitting on the same frequency channel as you're operating on, then you defer to it. You don't transmit until that other transmitter has finished their transmission. But in this case, what we're going to do is we're going to intentionally kind of step on that other transmission. I liken it to having a conversation in a crowded room. If there's someone right next to you talking very loud, then you don't try to talk over them. But if there's someone talking at the far end of the room at a relatively soft level where you are, you might go ahead and speak to someone who's standing close to you. So the idea is the same here. The colors allow an AP to transmit even when a signal is present on the same channel if it's coming from a different color. And as long as the transmission is from a different network, which is sufficiently far away, both networks can transmit at the same time without interfering with each other. So as you can imagine, from the example I gave about talking at a party, this can either be effective or it can just create additional chaos and collisions. The system needs to make a number of correct decisions again to make this work. Which AP gets which channel, which color, and what received signal strength should you go ahead and transmit on top of another transmission. So Wi-Fi brings these 160 megahertz channels. It brings BSS color, both of which require rigorous, intelligent optimization to ensure consumers benefit from these advances rather than suffering from them. Ofdma is, kind of the marquee feature for Wi-Fi 6. It's the thing that people talk about a lot. It's what promises this tremendous growth in the number of Wi-Fi IoT devices without overly congesting networks. And that's important because we see devices going up very quickly. Ronan was talking about some of the statistics they see. We did a study on our network, and today, 10% of our users have 40 or more Wi-Fi devices in their homes, and 20% have more than 33 devices in their home. And what we saw also was that number grew by 25% across the last year. If you project that out, by 2025, 10% of homes might have as many as 100 Wi-Fi devices in them. Now, I'm not guaranteeing that kind of growth rate will continue. Last year was a somewhat unusual year with COVID and everything. But it does indicate that the number of Wi-Fi devices in people's homes is growing very rapidly, and could become a real issue for Wi-Fi networks. Now, the way OFDMA works is that it allows an access point to put together a single transmission which contains a small amount of information for each of many receivers. By combining what would have been many transmissions into a single packet, a large amount of wasted airtime is saved. However, more and more homes are getting multiple access points to ensure good coverage and high data rates throughout the home. It turns out this presence of multiple APs can make it difficult for OFDMA to do its job. You know, here there's an example shown here. Imagine a home with 8 IoT devices in this example and 4 access points. If the IoT devices are kind of distributed among all the APs in the home, there might be only 2 devices per AP. So what this means is that each AP can only aggregate 2 devices into their OFDMA transmissions. And that really limits the amount of benefit that you might be able to get from OFDMA. A potential fix would be to have only one AP do this OFDMA function and move all of the IoT clients to that access point. The problem with this approach, you can kind of intuit from the way this is drawn, is that some devices might be too far from the access point, requiring transmission at a very low data rate, again, destroying any potential efficiency gain. You know, when devices get out to the edge of range in a Wi-Fi system, they start transmitting at a low data rate, they take a lot of airtime, the whole system becomes inefficient once again. So for each home, you know, kind of like as I liken it, the story of Goldilocks and the 3 bears, for each home there is a kind of just right solution that balances this aggregation desire to get a lot of devices on single access points so OFDMA can be effective with the ability to connect to nearby access points where your signal strength is the strongest and where you can go at the highest data rate. So the correct topology for each home will be different, depend on the clients, the traffic patterns, the layout of the home, and the access points in the home. And so again, what's really required is an intelligent system that optimizes the network and sets it up individually and in a different way for each individual home. So Wi-Fi 6 brings 2 features that try to manage airtime for advantage. Target wake time. Again, this saves power by reserving time slots for sleeping devices to wake and communicate. And network slicing to reserve time and frequency slots for high priority data flows. As with other features, making these work effectively in a multi-AP environment is especially tricky. So there's a diagram here that shows a home that might have 3 access points in it and a bunch of clients, the clients distributed among the access points in the home. Looking at this, if we think about how this TWT or target wake time reservation of time slots might go, AP1 might reserve a TWT time slot for phone P1, for example, in this diagram. However, AP2 in the home might reserve an overlapping TWT slot for P2. So now what happens is the 2 awakening phones, which might in practice be fairly close to each other in the home, they wake up and they'll interfere with each other during their TWT slots. Either they transmit at the same time and collide, or they have to wait for each other to get done. That defeats the entire purpose of having the TWT protocol. The right thing to do is kind of complicated. For P1, it's important that AP2 reserve that TWT slot, even though none of its clients will use it. So on AP2, it's like, hey, I'm going to reserve this slot, but I'm going to reserve it for none of my clients to allow the right things to happen at AP1. On the other hand, AP3 might be far enough away that it does not need to reserve that slot. Finally, the TWT slots at AP2 probably have to be reserved at both AP1 and AP3. The possible scenarios for this, as you can imagine, are nearly infinite and depend, again, specifically on what's going on in each individual particular home. Now, similarly, network slicing, where we reserve slots for high priority traffic, needs to be coordinated across multiple APs as well. And network slicing has the added complication that some high priority traffic must traverse multiple hops. So it's got to go all the way across the network from end to end. And that involves hops in the backbone or the backhaul of the network, as well as hops out to the individual client. And timeout needs to be allocated for the high priority traffic flow, has to be reserved on each hop, considering whether that hop is on the same frequency channel as another hop in the home or whether it's on a different frequency channel. The scenarios shown here are for a multi-AP home, but similar scenarios can exist in single AP homes that have interference from neighbors or interference from other units within an MDU. And so coordination across multiple APs, both in homes and even between homes, is again particularly beneficial for Wi-Fi 6. If you really want to get benefit out of these new technologies in Wi-Fi 6 and the improvements that can come from them, you really have to be doing this sophisticated kinds of optimization. So Wi-Fi 6 is a big improvement, as much as we're talking about the complications of it and the difficulties of using all these new features. It is a big improvement, and service providers should be excited about deploying it. The question becomes, how do you get the technology, particularly in a way that enables centralized management that it really needs? It turns out there is a convenient way, and Ronan talked about this as well. Opensync is an open-sourced software agent that can be put on an access point, and it enables that AP to be monitored and controlled by the cloud. Opensync includes a software-defined networking capability, which allows it not only to manage Wi-Fi, but to implement other services as well, services such as cybersecurity, parental controls, and even Wi-Fi motion detection. Again, Ronan was talking about some of the ways that service providers can make up for lost ARPU as certain services are kind of drifting away, such as video services. And he mentioned, being able to rent new types of equipment and more sophisticated systems like Wi-Fi. It's also possible to bring new services into the home that consumers are very willing to pay for, that are different services and maybe had been previously supplied by service providers, such as cybersecurity, parental controls. Motion detection can be used to create a physical alarm system. It can alert me if I'm out of the house when there's motion happening. It also can be used as a wellness monitoring system. I might have elderly parents that I want to know got up in the morning and made it to the kitchen and had breakfast. Now, this Opensync turns out that it has grown tremendously in popularity. It's supported by all the major chipset manufacturers. It comes pre-integrated in APs from a wide variety of vendors. Adtran is one of those. And it has been adopted by leading service providers, both large and small. And now it supports Wi-Fi 6. One thing that's nice about Opensync is that if you put it into your system, it runs equally well on Wi-Fi 5, even going back to what was nominally Wi-Fi 4 and Wi-Fi 6. And you can even have mixed environments where you have some Wi-Fi 6 devices and some Wi-Fi 5 devices, and it operates very well on those devices as well. With the current silicon shortage, there can be supply issues, and if you're trying to roll out Wi-Fi 6 to all your customers, it can be the case that becomes a little bit challenging to do in the immediate future. That's another advantage of Opensync, is that you can deploy Opensync, this software technology, and still allow you to make a lot of forward progress even while you are still having Wi-Fi 5 or previous generations available in a lot of your homes as you're rolling out Wi-Fi 6 throughout your network. Thank you. So I do think that Wi-Fi 6 is a great, exciting opportunity, and I think that everyone should be looking forward to that and making plans to deploy that. But you have to tend to other aspects of your network as well and make sure that you have a good Wi-Fi management system in place that can benefit all of your Wi-Fi systems. Thank you.
Thank you, Bill, and thank you, Ronan. We now move to, and I'm gonna maybe share my screen in a second, but while I'm doing this, we already have some questions coming in, and I will immediately move to the first one. Interesting one. If you were to, and it comes from, I think, Rebecca, and she's asking us, if you had to pick one, what is the biggest challenge customers are expecting Wi-Fi 6 to solve?
I guess I could
want to address this one.
I was on a panel at one time where they actually had a survey question about that. And the highest response was actually interference, congestion problems. And so I thought that was interesting. And then the second was the handling of a large number of devices in the home. And I think that those answers are pretty perceptive in a way. You know, usually when a new Wi-Fi technology rolls out, there's a lot of focus on the higher data rates and so forth, and that part of Wi-Fi 6 I think is important. But I do think that it's more the interference and the handling lots of clients, which is, you know, the unique aspect of Wi-Fi 6.
I think also as well, there's probably a lot of the basics that are not well implemented in a lot of the existing Wi-Fi 4 and Wi-Fi 5 solutions that are out there today, that people kind of anticipate Wi-Fi 5 is, or sorry, Wi-Fi 6 is going to fix. Simple things like handover between APs in a multi-AP home, when not done properly, can result in a really frustrating and very poor experiences. People get stickiness as they move around their home, etc. And I think a lot of them kind of look towards Wi-Fi 6 as being the solution towards that, when in reality, it's not necessarily the Wi-Fi standard implementation that's going to help with that. It's more a better implementation in the software on the access points they're using.
Thank you. I have another question from Neil regarding the effective throughput we can expect to have from Wi-Fi 6. He's mentioning that in traditional Wi-Fi connection, according to him, the effective throughput is approximately 2/3 of the connection speed. And he's wondering whether Wi-Fi 6 changes that pattern.
I don't want to speak for Bill, but I think it's going to depend on the architectural implementation of the device that you're using as well. That has a large part to do with the overall performance that you can achieve versus the bandwidth that's available via the Wi-Fi connection. There's some of the other things that I've seen, like even simple things like, you know, we noticed at one point with my son's Xbox, when he was complaining, saying, "Dad, the Wi-Fi is not working." And I took a look at it, and sure enough, he was trying to download a game, and it was only coming down at 20 megabits per second. But yet his Wi-Fi connection, I checked it on the Plume app, and I could see the thing was connected at 250 megasecond via Wi-Fi. And I'm scratching my head because the broadband is 1 gig fiber connection, thankfully, these days. And I'm saying, what's going wrong here? And after a little bit of investigation, I just through troubleshooting with him, I said, "Are you playing a game at the moment?" He says, "Yeah, it's such and such on in the background." And I says, "Can you kill that game and just see what happens?" So he kills the game, and sure enough, all of a sudden, the download starts ramping up 100 meg, 150 meg, 200 meg. And I said, "Okay, start the game again just to see what happens." And he starts the game again, and sure enough, it falls back down to 20 meg throughput. Now, one of the things I've noticed now with the very latest Xbox Series X is they actually highlight that on the screen for you. They say, if you leave these games open, this is going to take longer to download. So some of the producers or manufacturers of the products are becoming aware that their product has a direct impact on the consumer experience over the Wi-Fi infrastructure. And thankfully, they're taking a bit of ownership around that as well.
Yeah, and I just add that, you know, Wi-Fi 6 does have some different modes of operation. But on the whole, you know, Wi-Fi as an industry has this tradition of quoting speeds by what we call the physical layer data rate. And that does not factor for all the overhead associated with some of the protocols that have to be running and protocols associated with IP protocols themselves. And so I think that the basic notion you have that is about 2/3 of the quoted physical layer data rate will be pretty consistent for Wi-Fi 6 as well.
Okay. I have a question from France, and he's wondering if Wi-Fi 6, he mentioned 6 gigahertz attenuation and frequency. How is attenuation compared to what happens with the different flavor of previous Wi-Fi, especially when it comes to, you know, going through concrete wall and brick wall? Bill, unlike the US, here in Europe, we have very thick walls, and we suffer from that constraints when it comes to wireless frequency propagation and attenuation. So is there anything different for Wi-Fi 6 from that perspective?
Yeah, so, you know, here in the US, we build our houses out of what could pretty well be described as paper, but it's true that in other environments, the houses can be built out of much sturdier materials. And it is an issue. You know, 6 gigahertz, the higher the frequency, the worse the propagation. The difference between 6 gigahertz and 5 gigahertz is probably not going to be huge because there is a, you know, on a percentage basis, it's not that different. We see noticeable difference between 2.4 and 5 gigahertz. And one of the things that Plume has in its system is very sophisticated what we call down steering, because you can have an advantage where as someone's moving further and further away from the access point, the best thing to do is to actually have them shift down from being connected on the 5 gigahertz band to have them being connected on a 2.4 gigahertz band. And we will actually kind of forcibly make that client downshift into the 2.4 gigahertz band so it can actually be connected better as it moves farther away. Now, the 6 gigahertz band has another complication to it, which is that under some circumstances, the allowed transmit power is less than in the 5 gigahertz band. And that's a complicated topic I didn't go into, but it has to do with whether you have what's called an AFC system that looks for other competing types of services in the area that are the primary users of that 6 gigahertz band, and that determines whether you can use the higher level power or the lower level power. But on the whole, yes, it will be the case that 6 gigahertz is even a little bit more challenged for propagating throughout homes. And again, it's another reason why I think you need to make very intelligent decisions, factoring where are the clients, where are additional access points in the home, how strong are the links in the backhaul between access points and so forth, whether to use the 6 gigahertz band or not to use it, because it is possible, despite it being kind of this new spectrum and clean and interference free and so forth, it is possible to make the network run worse using the 6 gigahertz spectrum than it would with just the 5 gigahertz spectrum.
I think also as well, Vincent, some of the things that we have to take into account for are things like the new building regulations as well. So increasingly we see, for example, the foil back building materials that are used in new homes for thermal regulations, etc. And they wreak havoc with any of the Wi-Fi systems, and 6 gigahertz is not exempt from that. And I think to that extent, it's still critically important, even though, you know, we're very much of a wireless mindset throughout the home. It's critically important that the APs, the gateways themselves, and the extender APs throughout the home at least have that facility available that they can take a wired Ethernet connection for households where it's just simply not practical to get RF to propagate through the materials that are involved.
Okay, thank you very much. An interesting question, at least from my perspective, from Thomas. What about power consumption of Wi-Fi 6 compared to legacy Wi-Fi? And may I maybe extend the question, what about the Wi-Fi 6, including its management carbon footprint, compared to previous generations?
Bill, do you want to go first or shall I?
Why don't you start?
Sure. I think one of the things that really drives power consumption across a Wi-Fi network is congestion. Whenever we get a congested environment where we get an awful lot of retransmission, basically the effort to achieve the same outcome is significantly greater. So having the extra spectrum available to us that Wi-Fi 6 can deliver, and also the extra capacity that can be achieved on the Wi-Fi 6 networks means transmission times are significantly less, which helps drive down the power consumption. I think when it gets into the cloud managed environment, there is the ability to power down things that are not actively in use as well. So there are opportunities for further power savings there as well. Now, obviously, you've got to offset that against the cost of the compute cycles operating within the cloud. But when you spread that over, you know, tens, if not hundreds of thousands of customers, I think that that additional cost adder or not even a cost adder, but a power consumption adder per user is negligible.
Yeah, and I think I would add the comment that, you know, although Wi-Fi 6 is a more sophisticated technology, it requires more processing and so forth, we are getting the benefit, of course, of semiconductor technology always evolving and becoming low power inherently by itself. So when we look at the Wi-Fi 6 solutions, I would say on the whole, it's kind of similar power levels from our observation as it was for Wi-Fi 5. A more sophisticated technology using a more advanced semiconductor technology kind of comes out equal. Okay.
I see several questions, and I'll take the one coming from Darie, and it's talking about how do we manage a mix of devices, some of them being based on older Wi-Fi model, and with the arrival of Wi-Fi 6 in homes. How do you manage this hybrid situation between the different generation of Wi-Fi 6?
So I can comment. Oh, Ronan, you go ahead.
No, go ahead, Bill, please.
Oh, okay. First off, luckily, the Wi-Fi Alliance has a very strong, determination to make sure that all new generations of Wi-Fi are fully compatible with the older generations of Wi-Fi. So, generally speaking, if you put a Wi-Fi 6 access point in a home, it will be able to communicate very well with Wi-Fi 5 devices. Now, what gets trickier is this new band. So, for example, the 6 gigahertz band, obviously, previous generation devices could not operate in the 6 gigahertz frequency band. And if you put an access point in the home that uses the 6 gigahertz band, none of those legacy devices are ever going to go up into that frequency band. And this is where we get into this complicated question about, am I kind of wasting my resources up in 6 gigahertz, or is that actually beneficial to me, particularly in the early days when there aren't so many 6 gigahertz capable clients. But the other thing is that certain of the new technologies and capabilities like OFDMA, they similarly only work with Wi-Fi 6 devices. A legacy Wi-Fi 5 device cannot participate in that OFDMA style of transmission. And so to the extent that a customer already has a large number of light bulbs or something in their house that are Wi-Fi 5 light bulbs, those are not going to get the efficiency improvement coming from Wi-Fi 6 by putting a Wi-Fi 6 AP in that home. But as consumers build a larger collection of Wi-Fi 6 devices in the home, they do get that advantage of OFDMA. So it all does interoperate, but not all of the features and benefits are accrued to the legacy devices.
Ronan?
To be honest, Bill covered everything I was going to cover, so it's
Perfect.
all good.
So maybe you can address this one. I mean, you mentioned in your introduction the fact that operators' business model could be impacted by all the evolution we're currently seeing. So looking at Wi-Fi 6 revolution from the angle of business model and how to market services, do you think that Wi-Fi 6 opens new opportunity and require a change in the business model of operator to leverage the services enabled by Wi-Fi 6, basically?
Without question, but over and above new services that we can bring to market and sell, particularly higher speed tiers, etc., and sell reliably, I think one of the biggest challenges that operators are facing into now, when I speak with some of the larger operators across Europe, increasingly I've heard the figure rise over the last couple of years where, 3-4 years ago, they used to talk about, they were very nervous, 40% of the support calls that they were dealing with were being resolved due to interaction with the Wi-Fi environment. That moved on to 50% and then onwards up to 65% as the years continue to progress, as that the WAN capacity continued to rise in excess of what people could achieve across the LAN, hence the support calls continue to rise accordingly with it. So for the operators to really get control of that in-home Wi-Fi environment, whether it's Wi-Fi 5 or Wi-Fi 6, I don't want to say it's irrelevant, because it's not, it's very relevant, but they can achieve far, far greater gains by just taking control of the environment and introducing automation into optimizing that environment as well. The way I've described it in other talks that I've given to the industry, managing a Wi-Fi environment is like playing whack-a-mole. You can do a truck roll and send an engineer out and they'll optimize a customer's house and it'll all be fantastic for a couple of hours. And then the neighbors come home and start to switch stuff on and the microwave is turned on and so on and so forth. And we get all sorts of interference sources that weren't there when the optimization occurred. And what do? Do you do another truck roll and send another engineer out to re-optimize things, etc.? You have to introduce automation to this problem. Throwing humans at this problem, it's just simply not scalable. And this is where, for an awful lot of the service providers, they're factoring in, we're building a full fiber network, so our maintenance costs are going to be a fraction of what the copper guys' maintenance costs are, because the fiber never breaks. And they're absolutely right, but the problem they're going to have is it's not the fiber that's going to be the big problem they're facing into. It's going to be that in-home Wi-Fi environment. As those speed tiers over the fiber become more and more ubiquitous up and around the gigabit range, that's where people are going to struggle to achieve what they're paying for. And when they feel they're not getting what they're paying for, they're either going to churn or they're going to ring the support desks.
We're getting to the end of the session, Ronan. Bill, maybe on this subject or on any other issue, do you want to have a few words of conclusion, because we shortly need to wrap up?
Yeah, I just echo exactly what Ronan said. It almost looks like like a layered system when you think about monetization of Wi-Fi 6. At the bottom layer, the basic thing is you have reduced support calls, reduced truck rolls, which saves money, significant money. Above that, you have a basic notion of customer satisfaction, and that strongly relates to churn. Rolling out new gear like Wi-Fi 6, pleasing your customers with exceptional Wi-Fi performance and capabilities and a more stable network. Churn is super expensive, right? It's even more expensive than truck rolls and calls. And then at the top tier are new services, and Wi-Fi 6 does enable some of these new services. A centralized management system, which has these additional features, can enable it as well. When we think about cybersecurity, we think about parental controls. Again, those can be applied either to try to increase ARPU. They can be a premium service that you actually sell, or they can be just a customer satisfaction element to prevent churn. So there's quite a few different ways to look at the monetization of it. But I think we definitely feel like this new technology makes customers very happy, and customers being happy is always worth money.
Well, thank you, Bill. Thank you to our audience, a very engaged audience. We could just take a fraction of the question you sent to us. As I said earlier, replay presentation deck will be sent to all participants. So I just want to thank Ronan and Bill for their insights. And I hope to see you again on one of our webinars. Stay tuned, you will receive invitation for the next sessions of FTTH Council webinar series. Thank you again, and have a good rest of your day.
Thank you.
Thank you.